Okay, so if you're not familiar with conservation districts, we were established after the Dust Bowl, and we're a non-regulatory agency, and there's pretty much a conservation district in every county in the US. So our programs are open to all. We work with a lot of private citizens. Like I said, we're non-regulatory. We're all about natural resource protection, and the natural resources that we focus on are really determined by the critical need in our area. So a lot of the things that we assist folks with in Pierce County and surrounding counties is water quality protection, but we also do a lot of other things. And some of those things are related to forestry. And if you have a healthy forest, you're not contributing to water quality problems. So if you want to learn more about our conservation districts, the one that you belong to, please check out our websites. We offer all sorts of services to our landowners. So we just received funding a year ago to hire some cluster foresters. What this means is Margaret doesn't work in our office. She doesn't work at the Pierce Conservation District. She's based out of the Mason Conservation District, as is Mark Mead. And they are foresters that we get to share with a couple of other conservation districts. So we really wanted to get the word out about what they're doing and their services. So we're having these webinars once a month for the next 4 months. And then we're going to do a forest stewardship day in May at a privately owned forest in Eatonville. So stay tuned for that date and location. So before we begin, I'm going to ask you to take the quick poll. So we have also Levi Love with us tonight, which is our AmeriCorps member. And Levi has to show that our workshops are gaining, the folks participating in our workshops are showing knowledge gain. So we have our pre-surveys and our post-surveys. And if you didn't take that pre-survey earlier when you registered, just like 6 questions, we're going to make you do it now before we start the webinar. So Levi's going to bring up the first poll. So just take a few minutes to fill that out. And I just want to say, we'd like to track who's actually showing up to our workshops. So if you can either change your name to the name that you registered under in your little window, or put it into the chat. That way we can track who's actually showing up to our workshops. And also hold your questions and just put those into the chat as the webinar goes along, and we'll have Mark and Margaret answer the questions once the presentation's over. Okay, Levi.
Okay, I launched the poll, so everyone should be able to see it. And I just want to say thank you to all of you for taking some time to do it. It allows for Pierce Conservation District to continue to have AmeriCorps members year after year. So thanks again. All right, we're about half submitted, so maybe just a couple more minutes or so and should be good to go.
Levi,
Yes.
when I did the pre-test, question number 1 had a different one at the bottom. Because I remember typing in that a friend of mine sent me your link or the link to the forestry thing. So has this survey changed?
No, there was just on Zoom, there was no option for you to type in an other. So we just had these select options, but I appreciate you telling me that and I will write that down. Thank you.
Okay. So I don't have to take it over again because I did it on my phone this morning.
Yeah, you should be okay then.
Okay, thank you.
Thank you. Yeah.
Can I ask a question real quick?
Yeah.
If we took the test earlier, you'll know that, right? So
Yes.
not to call it like double or
Yes.
something.
Yes, if you did that earlier, yes, we will know. And I will type that in the chat right now so everyone knows.
Recorded. Got it. Crazy.
Okay, Renee, that's about a little over half, and I'm sure a lot of people filled it out prior to joining the meeting. So if you're still working on it, then I guess just finish up the last couple questions, and I think you're good to go. And thanks again, everyone, for taking time to do that.
Thanks so much, everybody. And like I said, if you can either change your name on your little screen, so we'll know who actually is showing up to our workshops under the name that you registered in, or if you don't want that to show up in the recording, if you can put that in the chat, then we'll know who all is showing up for our classes. Okay, so I definitely want to welcome and make you know who our cluster foresters are. We've got Margaret Creeder, who is from the Mason Conservation District, and speaking tonight is Mark Mead. So before the presentation starts, Mark or Margaret, do you want to say what all services are available to these folks other than the workshop tonight? And then we'll start the presentation.
Go ahead, Margaret.
All right, so we provide several services. One of the big ones is we write forest management plans for small forest landowners, as well as connecting you with other resources about, managing your forest, different ways you can manage for invasive species, for wildlife habitat, and other such goals you might have for your property. And we can also connect you with financial assistance if that's necessary for managing your forest.
Okay, Mark, I've made you a co-host so you can pull up your presentation now.
Okay, great.
Take it away.
All right, screen 2. Is that Sharon? Great, okay. So Just to get started here, I want to make sure that you understand that this is not going to be your typical lots of scientific jargon and the like in terms of forest health and risk trees, because this is one of the approaches that we want to take is make this as friendly and as approachable as possible. Once again, we are representing Kitsap, Mason, Thurston, Pierce, and King Conservation District through cooperative ventures. A lot of what we're going to be talking about is ubiquitous. So I'd like to go ahead and get started. Got a lot of ground to cover, and I'm going to go a little fast, but questions are always helpful at the end. The first thing that we want to talk about is that I think everyone has a pretty good idea of what the importance of forests are to us in general. That there's economic, there's health, there's water quality, there's wildlife, there's all sorts of values to the forest and trees. This is actually a really cool website that you can go to find out how much your tree generates in terms of economic benefits in an urban setting. We also know that trees provide for us some sort of physical and also mental health. And so one of the things that we look at in urban forestry is how that happens. But one of the things that we do know and that we do want to take forward with us is that trees grow, and as they grow into forest, it's a dynamic process and it's always changing. This process can be through the lifespan of the tree and lifespan of the forest, and it changes from time as time goes on. And there are a number of different pathways that growth can go through. And a lot of times health is determined by where the trees are in this pathway. But one of the things that we talk about is where that disturbance occurs in this forest habitat. And that disturbance and that change that happens in the forest can be anything from us logging it to us doing some sort of a fire going through or disease. And so we talk about health in these terms. But this changes in health are actually incredibly important for the health of the forest. And the important part that we need to look at is how this diversity, how habitat, and all of these things are impacted as the tree ages and declines. And so what happens in a forest is we have a change in our structure, the overall composition, and it also impacts forest health, impacts how this forest will succeed from one end to the other, or a process we call succession. Some of the measurements that we use for forest health are the diversity in the forest. And in some places, what we look at is, in particular in the Pacific Northwest, you'll notice that there's 14 different tree species. There's over 47 different types of forbs and ferns growing in our forest, and 32 different types of shrubs. The other thing that we look at is, in terms of health, is how many tree species are available. And we'll talk a little bit more about that later on in the project here. One of the things that we also look at is forest productivity. And we can look at forest productivity as being a measure of health. How fast are trees growing? Is this a good forest? Is this a bad forest? Is it producing what we want it to? Now, one of the things that's really important to understand when we look at a forest is that we're putting our eyes on the forest and we're making decisions based upon what it is we want. And those goals that we have for that forest determine the value of that forest. And then that value is going to determine how much money and time we're going to put into the health of that forest. This is a really important concept. And when we talk with as conservation district foresters, this is one of the things that we really want to talk to people about is what is important to you. All these forests that you see here on the right side have value. They have health. They are healthy, but they have different structures and they have different forms. And these forms can be measured in many different ways. And the numbers of trees, the numbers of dead trees, the clear air that's coming out of it, the clean water, whether or not the forest looks good, the number of insects, the lack of insects, the number of wildlife, the amount of wildlife, the overall structure. These are all things that we can measure to give us an idea of health of the forest. So one of the things I wanted to do today was kind of take a look at it in a little bit different context and look at it in terms of what it's going to take if we have an unhealthy situation to fix it. And so when we look at plant needs, some of the basic plant needs, I think we all know that plants need water, they need light, they need soil, but they also need air. They need oxygen, they need carbon dioxide, they need an appropriate temperature, they need time to grow, and they also need room to grow. So when we go through looking at health, one of the things we want to look at is it going to be easy to fix? And some of these things have a higher cost and some things are more difficult. So those are some of the things that I want to be talking about tonight. So I use very simple pattern of what I'm going out looking at the forest. I look up, I look down, I look all around in a forest as I'm going about judging the health of a forest. And why is that? Well, this is an example of a one tree, the Pacific Madrona. And if you'll notice, these are all the different types of diseases that a madrone can get. And if you look at the types of diseases and where they're located in the tree, they're in different places. And if we look just at one part of the tree, we're going to miss it. We're going to miss a problem. So this is one of the reasons that I use this little nomenclature to get my way around the forest. The other thing that I'd like you to look at is, as you're going through the process of looking at your forest, get in mind a reference forest. And by that, I mean, take a look at the forest around you. What's going on in the forest that you have, in the forest that you see around you and surrounds you? And what kinds of forest health issues can you see? This is really important because that frame of reference, what you're seeing with your eyes, how you're going through it, is what's going to help you to determine how your forest is growing and whether or not it's growing well and whether or not the trees are growing well or if there's a real problem. So first thing that I tell people, look up. It's just a matter of looking up into the forest. So what are we looking for when we look up? Well, first thing, I use this as kind of a way to look at it, is look up on a computer or look up in a book where your forest is growing, where your trees grow. Plant hardiness zone is really important because that's telling us where the trees live and whether or not those species is appropriate for that site. Next thing that we're looking at is canopy cover. We look up through the forest to get an idea of how crowded it is, whether or not there's enough light getting to the ground and whether or not there's enough light for the forest. The other thing that we're looking at is canopy spread, as well as a measurement that we use, which we call live canopy ratio. Now, the live canopy ratio is really important for us because what it does is it says basically how much of the tree has foliage on it or has branches on it. And this is a measure of a number of things, but the most important thing is it's a measure of how crowded the forest is. So the next thing that we look at when we go through this is we want to look up, as we're looking up in the forest, you want to keep looking up. Excuse me, while I get back to my slide here. And we want to look at the color. And it's very interesting that you'd think that the colors, if it's not green, then it's bad. But there is actually an app for that, looking at how fast the tree's leaves are changing, what type of disease is in there, and it's based upon what they look like. The other thing that we can see when we're looking up into a forest or we're looking up into a tree is whether or not it's producing too many cones. And when we say too many cones, once again, it's relative to whether or not that tree is the same as other trees in the area, or if it's going through a process that we call cone production, and it's a stress response. The other thing we're looking at is the top. One of the interesting things about root rot is that it actually shows up visually in a tree at the top of the tree, and that's the first place that you'll actually kind of see it. The other thing that we look at is just the basic architecture of the tree. Is it straight up and down? So the question you're going to be asking yourself is the tree, does this look right? Is there something wrong? So that ideal forest, that ideal tree that we're looking at, is there something different going on here? So the first question I ask myself is, does that look like the right type of attachment on the tree, the right type of thing going on in the tree? And we'll talk a little bit about attachments later, but the problem with this is that it will end up growing like that, and we'll be looking at a problem. Now, you might ask me, why do I look at, and why are we talking about such a fairly simple complex idea, or a simple idea making it complex, or the other way around? And the idea is that once you look up into a tree, you can start seeing a number of different things that are going on. And any one of those things can indicate one problem or another. So the idea is just to look up, get an idea what's going on top of the trees, and get an idea of what you think might be going on. And so that we can determine whether or not the tree is healthy, whether or not the forest is healthy. Now, as an example, I just showed you that where it said it's an insect problem, but here we have Swiss needlecast, which is impacting the tree, and it's a fungal infection, but it has got pretty much the same type of impact that we would see in terms of the disease pattern of yellowing or darkening needles or brown red needles. The interesting thing again, as we look up in the trees, some of the top diseases in landscape trees, Phytophthora, Verticillum, Anthracnose, and birch borer, bronze birch borer, and emerald ash borer, all of these plants are impacted by the disease or the insect. Pretty much the same type of disease impact is seen first off in that we see it in the leaves, that we see it at the very top of the tree. And so this is one of the things that I'm trying to get across, is that we want to look at the top of the tree, get an idea what's going on in the tree, to get an idea what's going on, if the tree is healthy or not. Now, one of the things that we talk about, and this is where you can have 15 different talks about different types of insects, different type of insect impacts, different types of impacts on trees, specific insects on specific trees. And the question is, how do we know that there's a tree problem out there? How do we know that there's an insect problem? Well, if we know that we see that the needles are being bored, if we see that the leaves are being bored, if we see holes in the side of the tree, if we see leaves are being eaten, then we got a pretty good idea that something's in there. Now, the question that we have is, what kind of insects, kind of trees are impact free from insects? Well, basically none of them. For every disease or for every tree out there, there is a bug. And for every tree, there's the different type of disease. So that's one of the reasons that we're not going through every single list of every single tree out there and every single disease that could impact it. What we're really looking at is, what are the general characteristics that we want to be looking for? And so as an example, if we're looking for bees in a trunk, we know that we have in the trunk of the tree that we have some decay. If we see bore holes, see small holes in the trees, then we know that we've got some sort of borer. The other thing is, if we look at bark beetles and we see bark sloughing, and bark sloughing is basically the bark falling off. And we know that we have beetles that are eating underneath the bark. We have carpenter ants, we have sawdust. So basically what we're looking for is those signs that are going to get us going in the right direction. So one of the things, tonight's one of those nights where a lot of people are a little bit concerned about wind throw. And this is one of the things that I've worked on quite a bit, trying to address throughout the site. And when we look up, what we're looking for is, are the trees growing straight up, or are they growing in response to a problem that they've had? And there is a process called geotrophism as well as phototrophism, which basically the trees will right themselves. And that writing, and what's really important to understand, is that what we're looking for in these trees is the very top of the tree, the top 1/3 of the tree. Has the top 1/3 of the tree adjusted to the situation it's in, or does it have another problem? So when we're walking through a forest, this is the first thing that we want to be looking for in terms of an impact of wind or other issues on these forests. Now, recently, we've just gone through some pretty significant rains. I live out here in Shelton, out near Shelton, a place called Union. My road's been closed for quite some time due to slides. And I also dealt with this in the city of Seattle quite a bit. So one of the things to know about trees on slopes is that they're not going to stop a slope from sliding if the underlying geology is not stable. What they are going to do is that they will retain some soils, they'll reduce erosion, and they're going to actually pull water out of that slope, dewatering the slope. And they're also going to reduce the amount of water that's getting to that slope by both intercepting the water and through transpiration as the water hits those leaves. coming down. So it's important to note that trees are important for managing slopes, but they're not the be all to end all on slopes. So it's another thing for us to keep a lookout. Now, the next thing that we want to be doing is look down. And so one of the best ways to do that is to look down, is to look at the soils. And you can do that to the USDA Web Soil Service. And you can go online and find out what your soils are in your location and see if those soils are amenable to the species that you have. The other thing that you want to be looking for is how much water is on there. Is there water, too much water? Is there a little bit of water? Is there water all the time? And so this is something that you want to be looking for on a regular basis, as plants do not like to be sitting in water. Most plants don't like to be sitting in water for very long. They can survive it, but it's interesting to note that in some places, the same trees that do well in a urban setting do well in a drought, in a submerged setting. So we look at the forest in terms of how much water is in the soil and how long is that water going to be there. The other thing that we're looking at in a forest is what's growing under that tree. Are there a lot of shrubs? Are there a lot of grasses? Is there nothing underneath the trees? And we're going back to our issue of diversity. Are there a lot of different types of plants growing? That's another measure of health. And then the other thing that we're looking for is mushrooms. And as we probably know, is that those things are a sign of fruiting bodies or a fungal body that could indeed be root rot. So one of the ways that we do this in a forested setting is that we go out and we set out a grid pattern, and we'll look down at the forest soils and we'll try to get an idea of how much growth is going on of different types of plants. You'll notice in this one that we've got some down wood, and we'll talk a little bit about that later. So we do look down. You're looking down, you want to get a good idea what's growing underneath the trees and around the trees. One of the things that I like to note is that in terms of roots, is that roots do not grow down. That is one of the things that a lot of folks, we seem to think, or we get the message through our different types of our learning process, and we think that roots grow down. In fact, roots grow out. They can't grow too far down because they need oxygen. The roots are not protected by soil. Compaction can be exceptionally difficult on all sorts of types of trees, depending on the type of soil that we have. And that the roots are not as strong as the wood that's above ground. So in that the roots grow beyond the drip line in a lot of places, and especially in the forest, the root systems are going to intertwine. The other thing that we're going to be looking at as we look at a tree is, and we're looking down, we're going to be looking at the root crown. Now, the root crown is where the tree comes up out of the ground. It's incredibly important because it's the transitional part of a living and breathing plant. And it's very important because what happens in this place is that the wood fibers transition from one type to another, and they actually show us a lot of what's going on in the tree. And then a lot of times, especially in urban areas, this is where we can run into the most trouble with trees. And this is where we start to look at things like, can you see the roots actually winding around the tree, strangling itself? Is the tree, is this a point of decay? Do you see one side of the root system is higher than the others, potential uplift? Do you see that there is, once again, we're talking about look at the top of the tree for root decay, we're going to see that up on top of the tree. So sometimes this is really hard to see. And then the other thing that we ought to take into consideration is that those root rots that we talk about, just as I mentioned earlier about insects, they're just as variable and they're just as prevalent across the country and across the different species that we have. And so ultimately, there is a disease for every plant. And the reason for that is because if we didn't, we would have too much forest, too much downwood throughout our sites and throughout our forest. And this is what the diseases do, is they eat the trees, they eat the down trees, and they create that successional change in a natural setting. This is what one of the things that will make that change. So one of the reasons I'm bringing this up to you, the root diseases in Oregon, Washington conifers, is that one of the things you'll note in this diagram here, in this chart here, if you can see it, if not, over here on the left is a list of all the tree species in the Pacific Northwest, or most of them. And what you'll see across the top in the blue is the numbers representing how severely they'll be damaged by one of the 5 root rots that you see up above. You notice that almost all the trees have at least one, if not more, types of root rot that are going to impact them. This is kind of important for us to understand, because one of the things that happens in a forested setting is that people become very cautious about the idea of having root rot, but it's a natural process, and it's one of the things that we deal with on a regular basis. Now, once again, and this may be a little bit difficult for you to see on the screen, but if you look at the top 3-4 categories here in terms of things that are going to be showing up for root diseases, it's going to be a reduction in height growth, yellow foliage, a slow loss of foliage, that distressed cone production, and a slow crown decline is going to be indicative of the first 4 root rots in almost every tree. So once again, it's not that we're trying to make it less complicated or that it isn't complicated. It's just that there are some things that are very common for us to be looking for as we go through our forest and we're looking at the overall forest health. So one of the things that we want to also do when we get out there is to take a look at the forest all around. Now, I say trunk defects and decay spots in the tree. The reason I say look all around is because I have been more than once, more than twice, have not walked all the way around a tree to see what's going on inside that tree. But I also would like to just understand people to understand that they need to take a walk around to get an idea of how crowded that forest is, and to get into that forest to see if there are other types of things that are going on that are beyond just the individual tree, and if there are things that have happened in that forest that are going to impact that tree or impact that forest. As an example, in nearby clear cut, has there been a lot of wind throw, and the wind throw could be a sign of disease, or it could be a sign that we just had a very strong wind come through that area. We can also be looking to see if there's construction that's nearby, or have new roads been put in. All of these things are going to impact your forest, and they're going to impact what's going to happen with that forest over the short term and over the long term. Now, one of the things that may seem a little counterintuitive is that actually a matter of health in terms of overall diversity and growth in a forest is actually the number of dead trees. And it's not that we want to see a lot of dead trees, but if we have somewhere between 10 to 15% of the trees in the canopy, in the upper canopy, are dead, the forest is actually doing fairly well. Anything above that, not so good. Anything below that, it's not being as healthy as it could, and it's not being as diverse as it could. The same is true with coarse woody debris. And coarse woody debris is that stuff that's on the ground that's fallen off the trees, includes the dead trees that have fallen down, includes the branches that have fallen off naturally, and it includes branches and needles that have blown off with the wind. So these are actually good measures of health. And it seems counterintuitive, but this is what we found. The other thing that we found when we're looking through a forest and we're looking through a neighborhood, for that matter, is that we want to be looking for overall tree architecture. Does it look right? Does it look good? Does it give us a safe feeling? And that's actually pretty important for us to understand. The other thing that we can be looking at is if there's been recent construction. Once I mentioned earlier, is that new roads have been put in, things that have impacted the root system. Are there cankers visible across there? Is there decay or cracks in the trees present? Cracks are pretty hard to see sometimes. And the truth of the matter is that those cracks are where the decay is going to start. The other thing that we're going to be looking up is there dead wood up inside the trees, throughout the trees, and in different places all around the tree. So we want to walk around the tree and get a pretty good idea of what's going on in terms of the overall growth of the trees. The next thing that we look at is these unions. So one of the things that's really interesting about trees is that for the most part, this Y-shaped or this very strong V shape is actually a sign of weakness. It's not a sign of strength. What we really want to be looking at for a strong branch union as we're walking around looking at trees is something more U-shaped. Something that isn't going to be as obvious as we walk around and we take a look around is some strange things. And as an example, this is cypress that I was working on. I was trying to figure out what this hose was doing here and whether or not it had been left when the tree was growing because the tree had been staked or what. And it turns out that actually the owner had put the hose in there to drain the water that had been collecting in the middle of the tree to try to reduce the amount of decay that was occurring in the tree. Unfortunately, it's not going to help, but interesting idea. Now, we talked a little bit about this, but we didn't mention it. Just like you and me, forests don't like to be crowded. They like to be together, but they don't like to be crowded all together. They, in fact, there's different layers within the forest, and I think we know this, but we also know that there's different levels of forest that are going different levels of trees. And in a normal growing forest, we can have 5 different levels of the same species, the same age tree at 5 different levels within the forest. And we use these terms dominant, codominant, intermediate, and suppressed to describe these trees that have been overcrowded and too crowded. And now the suppressed trees are the ones that are going to fail or not do so well. And that we use those terms to try to describe what's going on in the forest. And it's one of the things that we look at as a representation of the overall health of the forest. Now, in some cases, one would say too many of these trees are suppressed. Well, actually, that's a good thing in a natural forest, in a native forest, to see suppressed trees. Now, in a working forest, and this is, we make a distinction, is that these are forests that are grown specifically for growing trees for timber. And so we start looking at spacing in a little different way. And the way that we look at it is how much that spacing is taking up in terms of the amount of lost space that we could be growing trees versus how many trees we can crowd on there without reducing the growth of the trees. So we start looking at these in terms of a basal area measurement. And what that means is basically how much wood is on that acre. And as you can see, there's quite a bit of difference in terms of the amount of wood that's within these acreages, depending upon the spacing in between the trees. And in the forest, the way that we go about looking at that, and the way we go about trying to figure out what that is, we go out and we actually count how many trees are in a specific area. As in this is an example, it's a 1/10 acre plot. And what we're doing is we're going out counting the number of trees that are within that 1/10 acre plot. We're looking at species, we're looking at health, we're looking at all the different characteristics of the tree to give us a representative sample of what is going on in that forest. It's not 100% sample, but it gives us a pretty good idea of what's going on. Now, the question going back to, and we talked a little bit about this earlier, is what's the fix? How do we go about fixing an unhealthy forest? Well, an example of a forest that is overgrown or has too many stems for productive purposes, we can go in and do stand improvement, which is removing a specific number of trees, removing the unhealthy trees, the crowded trees, the suppressed trees, to improve the growth of that forest, to improve the productivity of that forest, to increase the number of trees, the amount of wood that we're producing on that forest over the long term. The other thing that we can do is if we have an unhealthy forest is we can go through and we can replace the species. We can actually clear out the trees that are diseased. We can rotate the species, meaning that we go through and we take a different species going through at a different level. So we can rotate between conifers and we can rotate between different species of conifers. We can come in and we can cut, we can harvest earlier and start our forest over again than we normally would based upon that presence of a disease or an insect. Then the other thing that we can do is we can help develop resistant cultivars. And those are plants that are more resistant to whatever insect or disease that we're looking for. And there are natural processes by which a tree will help suppress outgrowth. But the other thing is that we can look at this in terms of how much time and energy it's going to take for us to treat that stand and how we're going to go about fixing this problem. And so as an example, in the Western white pine, which was actually used to be a dominant species in the inland Washington state, we had a great deal of issues in regards to the loss of that due to the introduction of a fungi that was very specific to the species. And it caused quite a bit of problems for us. And we actually lost quite a bit of our forest, our Western white pine forest. So when we looked at in terms of how we go about fixing that, how do we go about fixing it? We can fertilize it. We can come in, we can spray it with a herbicide. We can go through and we can remove the stumps at a great deal of expense, or we can even do simple things like pouring borax or other products on it to try and do that. So the question becomes not so much, can we do the work, but is it going to be something that we can actually do? And so one of the things I was going to go through with you real quick is just to take a look at this. It's going and asking the questions real fast. Can we get more water to a forest? Well, not necessarily. We're not going to be able to install irrigation in a forested setting. It's going to have a high cost to it. Can we increase light? Yes, we can go in and we can thin the forest. We can increase the amount of forest that we have. Can we change the nutrients in the soil? Yes and no. We can try by going out and adding fertilizer, but is that a cost going to be something that we can actually change? Now, in terms of air, can we actually change air quality, overall air quality? That's a good question. Temperature, whether or not we can actually change the temperature. Our temperature is changing in our in some of the forested areas around here. So the question is, can we change that? Not so much, but we can probably create some change through shading and increasing the amount of shading that we have by increasing the amount of shade that we leave behind when we plant. Can we do anything about time? Not really. We can try to plant older trees, but the fact is that on a forested level, it'd be incredibly hard to do. It'll cost us a lot of money. Can we increase the room to grow? Yes, that's a very easy yes. We can actually increase the spacing between trees, and we can actually plant in more places. So real quick, I'd like to get into risk management. One of the things that we can't really say is that risk, there is avoidance of risk, but there is no such thing as no risk. I will tell you that I do both of these things, and the one on the bottom, I actually feel safer. So it's really how you define risk when you're doing the bottom one versus the top one. And so when we talk about risk in terms of trees, one of the first things that we look at is what is the target? What's going to get impacted? Is it something that can't be moved? Is it something that can be moved? And if you can move it, let's move it. If we can't, if it's something that's moving, it's moving on the road. Can we get it out of the area? How far will that tree fall? So this is kind of a trick question. It's not necessarily where the tree will fall, but what's it going to hit and whether or not it's going to hit something, and that thing is going to stretch further out and cause more things like a telephone pole. So the causes of these impacts are, once again, these are all abiotic or biotic. They can be things that have to do with that are at the tree, the impacts of the disease, impacts of the the plant landscape or the trees being planted too deep, could be the root structure's been impacted, saturated soils, could be wind speed, could be rain, snow, ice. All the things are going to be impacting how a tree reacts to the situation that they're in. So one of the things that we're going to be looking for, and we talked about earlier, is how is a tree reacting? Now, trees can withstand things like of strong wind, can't withstand strong winds all the time, or they can adapt to that. And it's just a matter of getting the tree to adjust to that situation and giving it time to adjust to that situation. Things like soil moisture is really important for us to look at. And that's one of the things that's a big determinant of windfall in our area right now. So once again, we go back to the idea, this is not Gallagher, if you guys know who that is. And the reason the melon is there is that's the sound that it makes when you thump a tree that's hollow with a rubber mallet. It kind of makes the same sound as nice ripe melon. But we do have tools that allow us to look inside of a tree without cutting it open. And that's what that tool is over on the side. The other thing to remember is that just because a tree has decay in it doesn't mean that it's going to be falling down soon. So one of the things that we look at when we're looking at it is we have a likelihood rating. Is the tree likely to fail? Is it improbable or imminent? And if it does fail, is it going to impact something? Is it going to actually hit something? Well, if it's very likely that it's going to fail, it's of imminent failure, and it has a high rating in terms of the potential of impacting something, it's very likely that it's going to fail. It's going to cause a problem. However, the next thing that we look at is whether or not that very likely tree to fail, which is over here on the left-hand side of the column, is going to fail. And is it going to hit something of consequence? Is the thing that it's going to hit have a very high rating in terms of its value, i.e. a human being? Or is it going to be something like a small shed with some very rusty equipment in it? So the question there, once again, it's whether or not it's something of consequence for us, something of value. So this is a matrix that we use when we're assessing tree hazard. The next thing is that if you don't have enough hazard trees on your property, you can actually create them yourself. And you can do that by topping, by doing different types of pruning process on these trees that will actually enhance the ability for these trees to fail. The question got asked earlier today, and I'll go ahead and answer it really quick, and that's the unfortunate situation with big leaf maple, which are in decline in this area. The dieback is not known at this time. The cause of it is they're thinking it has a lot to do with the drought and heat issues that we're seeing with climate change. But one of the things that I wanted to point out too was that there's another culprit in terms of big leaf maple decline. And that has to do with the fact that majority of the big leaf maple, especially in urban settings and a lot of forested settings, are the product of coppicing, or basically their regrowth along the stumps of the trees. Now these regrowth, what happens here is that the decay in the stump actually translates up into those stems that you see growing. And it's a race between the growth of the tree and the spread of that decay. And that's why you'll see a number of very specific or large failures in old big leaf maple at the trunk or at the base of the tree. Another one of the ones that I really target and I like people to keep an eye out for is cottonwood. And this is because it has a very specific response and primarily in hot days that come right after rains, and where they'll suck up too much water and they'll actually pop a branch off. And unfortunately, those branches that they pop off are pretty significant. And so it's pretty important that when we're walking through our own properties and we're looking at other properties, so we keep our eyes up and look up to see what's going on in that forest, and specifically in specific trees. A side note real quick, in terms of trees don't really need to be pruned. We prune them because we want to. And so we prune them because we like it that way. We think that they should look a certain way. But then a lot of times we cause those problems. We can prune by doing it correctly, and we actually will achieve a safer and healthier tree. But one of the things is we have to work with the tree. So going back again to the fix, hazard tree abatement, we can either remove the tree or remove the target. We can reprune the tree to reduce that hazard. We can cable it. That's something that you have to make a value judgment on. Is the tree more valuable than the thing that it might hit? We can turn it into a habitat tree. The other thing is continue to look up. Last story about habitat trees, just make sure that they're in the right place. Just remember that also habitat trees, snag trees, are incredibly vital to the overall ecology and health of ecosystems, and they provide habitat for innumerous numbers of insects, disease, plants, wildlife, and they provide for really interesting structures that help break up our landscape. Now, going back to this little chart in an urban setting, and we're looking at individual trees, can we change the water? Sure. Can you add more water to it? It's not that hard a problem. Light, kind of an interesting issue, but we can do that by just making sure the right tree gets in the right place, and we don't shade it, or we do shade it, depending if that's what the species wants. Nutrients to soils, yes, very easily. We can add nutrients to soil. There's not that much ground to cover. We can get in there. Air, well, that's another question. Can we actually change the amount of oxygen, CO2 that's getting to a tree? Temperature, Maybe, once again, shade is an important part. But one of the things that we can try to do is keep trees away from places where we know they're going to have trouble, or vice versa. We can bring trees into a place where we want to change the temperature, and they will do a great job of changing the temperature. Time, yes, we can do that a little bit easier because in an urban setting or in a planting landscape setting, we can plant trees, but the cost is going to be a lot higher. We can plant almost full-grown trees, but the cost is going to be a lot higher. Last thing is, do they have room to grow? Well, no. One of the premiums on an urban area is space. And so that's really going to be a high cost. So it's one of the things that we have to take a look at in terms of value as we go through. Is the tree more valuable than what we want to use that space for? So finally, the common. What we're looking for in terms of a fix, that's what I wanted to talk about the most today, is that what I'd like you to be able to do when you go out in the forest, see what's common and what's not. You understand that we are seeing foliar diseases are increasing during the wetter springs. That's not unusual. You'll see that if you go through the seasons, that we get these warmer, drier summers. We're going to have more root disease. We're going to have more stress in our trees. And the other thing is that as things change, things are going to change. We're going to have to be looking forward and be expecting the unexpected. The other thing is, get help. If you have issues, you want somebody to take a look at what's going on out there with identification and specific things, look for the options or look for an expert to give you a hand, i.e. Margaret and myself. So the specific management options are what we're going to help you develop so that you can go through it. So ultimately, the fix is to get the right tree in the right place and make sure that you have a plan for looking at. And finally, look up, look down, look all around. And this is a really nice quote from one of your forest landowner up in Granite Falls. And one of the things is that he learned that he wanted to go from gardening to forestry, and he found out that it's more about working with your forest than it is actually putting our handprint on that forest. Thank you.
All right, well, thank you, Mark. And before we go to questions, we only have a couple in the chat, but before we go to those and then additional questions that people want to ask, we're going to bring Levi back to do a quick post-presentation survey. So none of you have done these, so I'm expecting all 45 of you to please fill this out to help Levi out and to help PCD to continue to get the assistance from AmeriCorps members, which we certainly value and need.
All right, thanks, Renee. It should be good to go.
Can I do the poll too?
Of course.
Levi, somebody wants to know if this is going to be graded. Will it be on a curve?
I will just compare them. Yes, I will download the results and compare the answers. All right, and we are 40 out of 42. So thanks again, everyone who did that. And thank you, Mark. That was an amazing presentation.
And just remember, we've recorded this. So if anybody wants to go back and study Mark's charts that he had to fly through, the presentation is going to be up on our website, piercecd.org, under our forest stewardship page, probably in the next couple days. Okay, so we do have several questions for you, Mark. So one is regarding unstable slopes. What would it be recommended to be doing forest stewardship activities on these slopes if they have unstable underlying geology? Example, trying to get rid of invasive species, planting more trees or shrubs on the slopes.
So to be quite honest with you, that's one of those questions, as I've worked on this quite a bit, is the first question would be looking at it from a geotechnical standpoint and getting a geotechnical engineer involved. It's incredibly important because the underlying, you don't know what's going on underneath. That being said, invasive species, especially English ivy and Himalayan blackberry, are much shallower rooted and don't do as good of a job as holding onto the soils, and can actually, in fact, cover up some of the issues that you're having. So getting invasives off and replacing them, and doing it in a consistent manner in a proper way, with some sort of cover after you get it on. And when I say cover, what I mean is mulching fabrics or hay or something like that, straw mats, not hay, sorry, straw, in there to make sure that it doesn't erode, and then make sure that you get plants down as soon as possible. And of course, don't do it during the wet season. That's probably not a good idea.
What is lifting in regards to pruning?
Lifting is going underneath. I use the word lifting the skirt. Basically, it's to take the bottom of the tree and using appropriate and proper pruning techniques, which is a whole other class, is to actually lift the bottom of the tree up, to get, if you saw that diagram, as you remember the diagram on the live crown ratio, is to lift that crown up a bit. And so one of the strongest recommendations for any type of pruning is no more than 1/3 of the canopy of the tree should be removed at any given time. And the most typical one, what we see doing that is so you can get your lawnmower underneath the tree and then bang it into the side of the tree so that you can give it some nice wounds on the bottom. That's usually what people do.
Okay, so the next one is, if a gravel area used for years for cars has much bigger vehicles coming on it for a construction project, is there a way to protect the trees from compaction of the roots?
Yes. One of the easiest ways to do that, of course, is through some sort of plywood or planking, putting it down over the top of the trees. You can also go in with the gravel and put on more gravel, which is not so good. But the other thing you can do is put down some wood chips, pretty dense wood chips. But then again, if you want to return it back to gravel, it's going to be a little difficult. So once again, it's going to be a matter of making sure that you have an idea what you're going to do with that land afterwards.
Okay, so do large transplanted trees do as well as planting young trees?
No, I think that's a trick question somebody's asking me, because the fact of the matter is that a lot of studies have shown that the younger you can plant a tree, the faster it's going to grow. So in some cases, if you put a 10-year-old tree in the ground or transplant it, and you plant a 2-year-old tree right next to it, in 10 years, the 2-year-old tree will be healthier and better and growing faster. It's just simply because you cannot transport the root mass that goes with the larger tree.
Somebody's wondering, what are the correct answers for the poll? Do you have the questions on hand, Levi? Are you still here?
Levi's gone.
Uh-oh, Levi's gone. Well, I will email out the correct answers to everyone after tonight. Okay, so next question is, I volunteer and work in areas with lots of cottonwood trees. Should I be aware of branch failure in the heat of the summer? We don't work around them in the high wind.
Yes, most specifically, if you see, once we talked about that, we talked about the branch architecture. One of the things that you want to be looking at is those trees that have very significant branches. And if you ever looked up into a cottonwood, it's amazing how large those branches can get at 100 feet up in a tree. Smaller branches, not so much. It's those very large branches that we're looking at. If you've ever looked at a cottonwood fail, you'll notice it almost looks like a ball and socket when that branch fails off of there. And so those are the structures that you want to be looking at, is the ones that have a poor architecture, or with cottonwood, it's actually the ones that are straight out are the ones most likely that are coming out perpendicular to the trunk that are going to fail.
Okay, Robin, you might have to help me ask this question because I'm not sure if I understand it. Any suggestions for fighting Himalayan blackberries using trees as a trellis until it has no light or even falls over? Are you
I
still
kinda
here,
get-
Robin?
Yeah.
Oh, there you are. You're muted, Robin. Hang on. There you go.
Okay, it still says mute. Can you hear me?
Yes.
Okay, my question is, we have a little patch of forest and the blackberries grow up and they use the trees as trellises and they climb right up the trees and drape over them. And frequently they will either bend the branches down, or even if it's a small tree, it'll just push it over and turn into a giant mound of blackberries. We've got so much water in the land, I can't spray. I cut them down at the base, they come right back, you pull them off and you're beating the tree up. Is there any solution for that?
Well, unfortunately not. The number one way that we can do this is to grub out what's called, the root mass, to get down there and get that gourd out. And just to do it consistently. The other thing is just to consistently go in and cut and cut and cut and cut on a regular basis. If you can't herbicide, you can use some herbicides that are aquatically labeled, but that's, it's your preference. It's just about amount of work. And then the other thing is, like you're mentioning, shading them out, the blackberry out with other species is really important, especially shrubby species, and getting in there. The other thing you can try, of course, is test it and try putting the bark, or not bark, but cardboard down and then putting wood chips on top. The interesting thing about that, what happens with things like English ivy and blackberry, is that they actually translocate into that upper surface and they become a lot easier to pull out. And whereas native species have a tendency to get underneath that. It's kind of an interesting process. But yeah, unfortunately, you're stuck. It's get yourself a nice sharp weed whacker. No, there's some really cool tools out there. There's a small size that have very sharp blades on them that are really good for the blackberry. And just walking through the woods and nice little gentle sway and cut them down, cut them down, cut them down. And just be careful not to hit the things you want to save.
Okay, so question about pruning trees in community working towards Firewise. Pruning trees to create space in ladder fuel reductions is a big battlefield.
Yes, the answer is yes. It is a big battlefield. So the number one thing to remember about that is that the concept is to create a distance somewhere between 6 to 8 feet between the lower growing canopy and the upper growing canopy. Now, the other thing to remember, which is really curious, and of course, is that you're actually mimicking the natural growth process of trees and forests, because trees do actually self-prune. So when we're looking at forests like over in Eastern Washington, where you have regular fires come through, the canopy is pretty high. The grasses are pretty low, and that's because the fires come through on a regular basis. But the truth of the matter is that in our old growth forests here in the Pacific Northwest, over here in the Puget Sound region, the canopies were pretty high, and that was just because it was translocating up. But it did allow for fires to come through on a fairly irregular basis. but that distance that we're talking about is natural. And so that is something that we want to see. And that's one of the reasons that they recommend that process. Now, is it something that's easy to accomplish and it's something that we need that can be done? No, it requires work. And going back to that little chart about cost to fix, that's one of the things that it's a cost that we have that we need to take into consideration when we're living in a semi-rural urban area that has this type of forest. And it's a cost. It's a cost of doing business. And so it's really important. It is true. It does help. And it can help. There are some other things, which is a whole other class. And Matt will be talking about that next week or in a month about what we can do to help protect your houses and structures. And the other thing to remember is that fire is actually a natural process. And it's probably one of the biggest ways that forests transitioned prior before us. Well, if you
Okay, I'm going to have to be the moderator and say we have like 20 more questions, Mark.
Okay.
So.
All right, 5-second questions.
Okay, how far out do tree roots go according to the height of the tree, specifically interested in urban trees?
Really depends on the species, and it depends on the soils, and it depends on the depth of the soils. I've seen cottonwoods and willows in some places go out twice the height of the tree. So it happens. It's important to understand it.
So what criteria should be used to determine when a dead tree or snag is not worth leaving as wildlife habitat?
If it's going to hit something that you like a lot.
Okay, is there a rule of thumb in how deep to plant a tree?
Yes, no deeper than the root collar. And that's what we talked, or the crown, root crown that we talked about earlier. That is the number one thing. Don't dig it any deeper than that.
Okay, here's another gravel tree root. How would I determine how much gravel to add to protect trees from heavy vehicles?
I see somebody has an issue. Actually, gravel is not something that's going to protect roots that much. Actually, what would be really important to put down is something that's not going to be as crunchy. And so putting down, you can put down, it really goes back down to the amount of pressure that's going to be put down. But in truth, wood chips, 6 inches of wood chips should be enough to save it. If you want to put down gravel, 4 to 6 inches of gravel should be fine.
Okay, so can you briefly discuss the consequences of planting just one species of tree, such as Doug fir? Are they going to be more vulnerable to disease? You know, what are the impacts on insects and animals having a monoculture?
So one of the things that we talk about, and especially in urban settings, and it has to do, it goes to 1/3 of a genus, population as being 1/3 of a genus. And the reason we talk about that is because we don't know what diseases are going to come in. And if you really want to go back to some things like, we just got hit here in the Pacific Northwest in the 2000s with Dutch elm disease. And if you know anything about elm trees, and you're back east, you know that elm trees were wiped out by a simple pathogen, and elm trees were the major urban tree. So one of the biggest issues that we look at in terms of forest health is in overall tree health is diversity. And that diversity is what allows us resilience, and resilience is what allows these forests to continue to live. So short answer to that.
Okay, someone's asking if they can have a copy of the slides, so I will get those from Mark and email them to everybody, and I will also make them as a link on our website. Please reference Dr. Suzanne Simard's work on forestry.
Sure.
After a burn has gone through, how can you tell if a tree will recover if there is green and brown needles, pines specifically?
Okay, well, that's going to take time. One of the serious issues that we have with bark damage is that you don't know how much of it got fried in terms of the cambial layer. And as everybody knows, a tree is actually only 2 to 3 cells of living tissue laid over a bunch of dead stuff. So what happened to that living tissue can in fact be spotty. So the tree can continue to live and continue to grow. It won't grow as fast or grow as nicely. But just like with any other type of root damage that we see in an urban setting or anywhere, you're not going to see that. You're not going to see that expression of that for 2 to 3 years, maybe up to 5 years.
Okay, well, actually, I miscounted and that was all the questions. So does anybody else have a question that they haven't typed into the chat? Doesn't look like it. Okay, so our next presentation is going to be a month from now, February 17th, something like that, third Thursday. And if you haven't signed up for that one, it's going to be on wildfire, making your home wildfire resistant. Yeah, it's February 17th. So feel free to sign up and keep an eye out for our forest field day. We're going to be looking at all the things that we're talking about in these months out at a property in Eatonville. So thanks everybody for coming. Thanks, Mark, and hope to see you all next month.
Great for y'all to come out. Thank you for coming. Appreciate it very much.